Thank you very much for organizing this event, and thank you for an invitation. And I'd like to introduce myself and then my colleague Artyom from our university. So I think I am associate professor from St. Petersburg State University of Telecommunication. And today I will try firstly to give some overview about 5G networks and some challenge and about our lab to introduce some projects which are working in our lab. And in this presentation, we are going to talk about this challenge, traffic recognition and long-term traffic forecasting based on artificial intelligence algorithms and metadata. In this talk, we are going to share with you next, can you, agenda, next slide. Yeah, some common background and about software-defined networking as part of 5G and related artificial intelligence technologies and our SDN lab infrastructure. I will go to talk about this part, and then Artyom will continue to talk in more details about our project, about problem with fastly traffic recognition on the data plane, about problem statement, key features, challenge, and research background examples, and also some tasks for participants and output format, what we require in this challenge to solve at the end. And then we can discuss maybe some questions if you have together about this challenge. So first of all, it is some common background. So as we know, with massive increase of heterogeneous wireless devices, for example, smartphones, machine type communications device and wearable devices, connectivity and traffic volume become design challenge for the 5G cellular systems. It expects that the data traffic in 2020 will be in 200 times more, much higher than 2010. And also for 2030, the data traffic will be in 20,000 times higher than 2010. So moreover, summary traffic is increased and challenge their profile, their distributions, activity, characteristics, hertz parameters, and others. So taking into account the new service based on Internet of Things technologies and their quality requirements for network infrastructure, expected that 5G IMT-2020 network will solve upcoming tasks and challenge. So 5G and parent networks like 6G network have to provide new technical requirements for realizing new services such as tactile internet, medical services, and others. In this picture, we can see based on ITU Air recommendation M2083, there are three categories. I think it's known for everyone. First is enhanced mobile broadband, ultra reliable and low latency communications, and massive type communications. The first one addresses the human-centric use cases for access of multimedia, content, services, and data. And the second one has stringing requirements for capabilities such as robot latency, availability, because there are new applications like tactile internet and so on, autonomous vehicles. For massive machine type communications is characterized by very large number of connected devices, typically transmitting a relative low volume of non-delay sensitive data So the capability of IMT 2020 are shown in page 2, compared with those of IMT Advanced. So as we know, according to this recommendation, future IMT will require more flexible network nodes, which are configurable based on the software-defined networking architecture and network function virtualization, NFV, for optimal processing the node functions and improving the operation efficiency of networks. So also in this case, the artificial intelligence algorithms are designed to solve adaptation network protocols and resources managements for services in practice for traffic recognition, classification, and prediction. Next slide. This we show the 5G architecture. 5G architecture, but there are many standards, many requirements. So we use this architecture. It's based on software-defined networking and NFV. To overcome the traffic load problem and the connectivity problems and to achieve the expected data rate with ultra low latency, 5G system shall employ new technologies, various location of the network. So some of these technologies should be employed at the core network. So here we can see example like software-defined networking, network function virtualization, maybe orchestration and other technologies. And other technologies are employed at the edge. They can offload the core network and also provide low latency. For example, mobile edge computing, device-to-device communication. Also, we have in our department many recommendations and works regarding to this area. So we are working to solve problems at the edge like security, maybe uploading algorithms based on deep learning, machine learning, and so on. We solve many problems. We had projects for some applications like autonomous vehicles for I mean to solve the problem with low latency to reach 1 millisecond latency. We built multi-level cloud computing. We did for that some algorithms, some uploading algorithms, and so if you are interested, you can check our work, our in ResearchGate or Google Scholar, our works there, or you can send in the email. We can share with you these works. Also, we have now new direction in the core with migration, with microservices. We are working in many tasks with resource allocation, orchestration, and so on. Second, last the slide with SDN lab. Yeah, this here you can see architecture of modern network of our laboratory. The core is built on the SDN technology with DWDM segment. We generate the different types of traffic. For example, Internet of Things. We have some models for smart city, is a self-developed generator with 960 flows, video traffic, and so on. So we use the open source solutions on the control plan. For example, here we can see OpenDelight. We use the last version, Trillium, which include the Open Linux Foundation. And also in this network, the data sets for artificial intelligence research were generated in this lab. Here, like we use real networks in our department and some devices, Internet of Things devices. which generate real traffic. And also we have our traffic generators based on which was developed in our lab. So we, I'm not sure. I will just some details about our lab. If you are interested, you can, because we have short time, you can send an email. We can give you more information. But we have cooperation with many companies, with Xerox, Microtic. Also, we have project with Canada, Flix, Sagia. We are working to based on new protocol, which was support developed there. We build our systems based on that. Also, we have cooperation with T8, this Russian company. We are doing some testing for their equipment, and also we are trying to develop some tasks. We have very big team, PhD students, masters, and bachelor students who are doing different tasks in this lab. So that's it from my side. And now I will introduce my colleague Artyom Volkov. He's one of the best PhD students in our lab. He will go to explain more details about this challenge.
Hello to everyone. My name is Artyom Volkov, and I would like to present you the more details about our challenge and tasks. If we're talking about the system of resource management and network management, there are following types of this network and resource management we have. This is manual type, automatic type, intelligence type. And in automatic and intelligence management cases, the traffic recognition task is necessary to solve it, taking account the new characteristics and types of services. And for this reason, focusing on the intelligent application demand of networking management and computing resource management, the artificial intelligence technologies such as machine learning and big data include the possibilities of the software approach in the IMT-2020. Now we mean that SDN and NFV technologies as the core technologies are applied to digital upgrades of internet infrastructure. And at the same time, as we know, the current directions in the technologies are SaaS approach for the end user, software as a service approach, and independence from the vendor solutions, for example, hardware and software parts. One more is open source in the platforms. For example, in our laboratory, we use OpenDelight controller. And for example, as you know, 1 of 10 specifications we have for realization in ITDM. And considering these actual requirements that were presented, new approaches and algorithms in the field of artificial intelligence implementation for info communication technologies should be developed based on them. And if we will talking about SDN technologies, we use the open southbound interface. It is the open flow protocol, and on the northbound interface, it arrest in the notation, for example. And based on the REST interface, we can work with the SDN controller like with the usual web services. And in this case, we have the opportunity to build AI applications which have all of the benefits of web cloud applications. There are scalability, independence of hardware, cross-platform, and live migration, and so on. In our approach, metadata flows used for making the models of each traffic. For example, it's IoT medicine, IoT smart road, IoT, smart city, video on demand, etc. on the data plan. At the same time, the analytic application with AI and machine learning algorithm is located on the service level and working with the SDN network via northbound SDN controller programming interface API. Usually API, as you know. So the metadata consists of flow metrics. You can see on this slide there are byte count, packet count, and timestamps of each of flow and ESDM switch. On the one of the figures of this slide, you can see the example of this data set. On the right part of the slide, the mathematical algorithm show it, which were used for recalculation from OpenFlow tables to data set, which we will use in neural networks. In this process, we've been calculating deltas between closely counting of each parameter and have been serving to a new data set, which we share it in GitHub. For the analytical system, as we were talking about SDN controller and zero principles, and all of the devices and flows on the data plan are the digital objects. And in fact, the system operates with digital twins of devices, traffics, and others, which we characterize by a set of parameters. So our challenge divided in 3 parts. Part 1 is about artificial intelligence technologies for traffic recognition. So here you can make the proposal for traffic types recognition based on machine learning using our approach with metadata. And second one part, this is proposal with long-term traffic forecasting on the data plan using when you can use metadata of recognized flows on data plan. And the third part is suggestion with theoretical models for both first and the second algorithms collaboration. Now we mean that you can make a proposal with a UML scheme in a UML notation with a definition description. So the proposed model should take into account the continuous work process of recognizing and prediction each flows. Like key features, if you will talking about what's the key feature of our approach, is user metadata flows on the data plan. At the same time, the application with this application is located on the service level and working with SDN controller via northbound API. So now we would like to show you some examples of our works. So on this slide, we want to show you the details of one of the research according to proposed problem statement and the part. We did a machine learning model for recognize IoT traffic and video on demand traffic based on the proposed metadata approach. And on the current figure, you can see that the structure of OpenFlow table and orange flow, which shows the research flow. So, and we developed the Python soft, which was sending the request via northbound SDN controller API, and in the result, we collected the data about this flow and made the data set based on the mathematical algorithm, which was presented above. So on the current slide, the presents the following: the structure of the data set of neural network, the architecture of a neural network. Neural network includes 2 parts, as you can see, is the LSTM, long short-term memory part, which can make the better recognition, and reckon on neural network type of this architecture. Input perceptrons, there are timestamp, byte count, and packet count. It's a structure of neural network in testing. mode. So, and as the output perceptrons, IoT traffic and video traffic, you can see on. So in addition, the results of machine learning model training were presented that the machine learning model was trained to 98% of probability, recognition probability, and also the main results was the hypothesis with the metadata was confirmed. And you can see the confusion metrics of machine learning model testing. In addition, the represented above results were published in Conference Journal, which indexed in Scopus and Web of Science databases. Now on this slide, in addition, we would like to show you one more example, which is based on the proposed method. And this work we perform an IoT traffic prediction approach using a long-term memory with deep learning and based on the collected metadata flows. In this article, we published these results in our article. We propose a structure with edge computing and testing controller, which include machine learning for the forecast preparing for the IoT traffic activity. The structure is distributed computer and monitoring system. On the edge computing, we can deploy a virtual open flow switch and make the input flow monitoring and make predictions based on the metadata of the SDN outbound interface. On the left figure, you can see the suggested structure. And about the neural networks training for the prediction occurrence, we use a root mean square error as a control function and mean absolute percent of error as additional function. So, and the results of these parameters monitoring during neural network training, you can see on the right figure. So, and the results, root mean square error was 0.93 and mean absolute percent of error was 2.4. So, and taking account of research problem directions, we have also experience and works with the practical results, which were published in the Web of Scopus and Web of Science conference journals. You can see now on this slide some examples. So, and again about task and output format. In this way, we presented tasks, this proposal of traffic types recognition based on machine learning using metadata flows, proposal with a long-term track forecast on data plan using metadata, and proposal with the theoretical models for both first and second algorithms, which can to presented in UML notation. So as the output format, we expected this will be the report, which includes the following. Problem analysis includes the gap analysis of current approaches for self-defined research problems. It may be your experience, you can present it here. The second one is the architectural schemes, models, algorithm in the UML notations, description of solution, which you will suggest. So results of modeling in the graphs and their explanation, software with machine learning, big data, and trained machine learning models. And of course, results in a KSV file, which contains results of training, its necessary parameters. As I told above, it is probability of recognition in the persons and parameters like root mean square error and mean absolute percent of error. In your work, you can use the tools Python with libraries, for example, TensorFlow and another one. So, and one more, of course, you can use a MATLAB for make your models and training. Thank you very much. We will happy to answer your questions.
Okay, thank you so much to our presenters, Dr. Amar and Atem, for the wonderful presentation introducing the SGN Lab as well as the challenge, problem student number 38 from Russia. Now we are going into the Q&A session. So I'd like to invite my colleague, Vishnu. It's time for the questions. So please take over. Thank you.
Thanks, Thomas, and thank you, Artem, and thank you, Amar, for that excellent talk. I wanted to ask you, you mentioned about open daylight. I think somewhere around slide 5 or so. Could you go back to the slides, maybe slide 5 or so? You had mentioned about open daylight and open flow. So I want to ask you if your lab contributes something to the open source or not. The reason I'm asking is you mentioned about northbound interface as well, and using this interface from the northbound interface, metadata from the northbound interface for machine learning. That is an interesting topic. Of course, that is the topic of the challenge. So in that context, do you have current relationships with open source? Do you do some contributions? Or the students there's some contributions. Could you please tell us about it?
You mean contributions about slicing, you mean, or?
About any aspect of the open source, to open flow or open daylight.
Yeah, we are using only open source solutions in this, but we add some our solutions based on some creation microservices, and we use different orchestration like OpenStack and another also open source technique. That's Artyom. Can you add some?
I would like to add some information that open source now in a platform solutions is the trend in software developing and in 5G different systems developing, as you know. So, and we think that is very important to test in open source solutions, and in open source you can find the big community and answers on your questions, and the solutions are developing so quickly, and I think it's better in a platform solutions. But here, for example, we're talking about services. It can be commercial and another one. In our lab, we use open source in controllers and also for orchestrating. We use OpenStack.
Thank you. So do you think that the information that the metadata that you talk about can be contributed? Is it in addition to the use of open source? Is it something additional to open source that the metadata that you use for this particular this kind of problem? Is it something additional that you look at contributing to open source, to adding to open source?
Metadata, we collected the data of flows. We carted in our requests to controller, and we collected data based on statistics of each of flow, and it's our approach which we suggested, and this suggestion was confirmed, and I think that this method can be extended on another one solutions. For example, when the light has different versions and different documentations of API, but this method and this software can be changed for the new API and also include all of the benefits of our proposal.
Yeah, I think that would be interesting to look at what you can contribute and what as the problem statement is solved, what can we identify as contribution to open source. Here is a question, another question from Alex. He's asking your published approach to traffic classification task attained high accuracy. Do you recommend that we implement your neural network architecture as a start and then to improve upon those results? So I think the question is that where do we start? Do we train the neural network from scratch, or do you provide a base implementation in your papers? Published papers, I guess that's the question.
I think that yeah, it will be better if you will make that suggestion with a new architecture. For example, in our case, we use it as you see in our presentation. We use the LSTM. We use a hybrid neural network which consists of LSTM and RNN. So we hope that you will suggest the new neural network, which can be more efficiently, I mean about time training or another one characteristics. Of course, it is evaluation criteria. So, and yeah, if you're interested, we can share in our neural network. It's not so big problem. We can share in our website of this challenge. I mean, of our problem statement. But it will be better, yes, if you will proposal with new neural network architecture and approach.
Thank you, Artem. I wanted to look at, let's say, slide number 6 or so. I think, yeah. So this one. So you had this service plane. I wanted to ask you if you're using any service orchestrator here, or it really does not matter. Because you do have open flow switch, you have SDN controller there, and the service plane. It is clear that you are using different types of traffic, but the question is, what will you do with the output of the neural network? Okay, so now you have recognition, traffic recognition. All right. So now what do you suggest to do with the output of the traffic recognition? I'm guessing that you are going to use it for some kind of orchestration decisions, maybe resource allocation decision or something like that. Could you please tell us what are you planning to use the output of the inference in this case?
Yeah, I think I will go to yes. For example, we can like recognition or recognize or like the load or overloading or something like that, and using orchestration we can through API interface build our applications to maybe manage or do some solutions for that. Yeah, please. Yeah, it can be usable for this.
in that case, yeah, thank you. I think I understand the solution better now. What would you need a service orchestrator, or would you use Open Daylight again? I think in your other picture, if you go back to your other picture, yeah, so this one. So here you have Open Daylight and OpenStack. Would you need a service orchestrator similar to what we have in OwnApp, or is the output used directly by Open Daylight?
Usually we are using open source solutions. This Open Daylight is like controller, but orchestrator, we are using OpenStack. It's also open source. But there are too much, like some students trying to use Kubernetes like orchestrator. He can do the same task like this OpenStack. But if you have open source orchestrator, yeah, we can use it in our lab.
Okay, thank you. I also
I would like to add one
yeah.
information. So we in task which we publish it, we're not using the orchestrator. Orchestrator we using when we want to, for example, make the system with not only network management, and which includes different services for resource management. For example, firstly, we can recognize traffic, and the next one, we can understand where is the service of, IoT application is located in our network. And for solving this task, we working with orchestrator, but in a current challenge, we're not using the orchestrator. It's only as in controller.
Okay, yeah, thank you. That is clear. Let me ask you, while we are in this subject, I wanted to ask you, because you're already familiar with the work of ITU, you're already active in the study groups. That's why I'm asking, how does this, do you see the role of standardizing the metadata? So in this problem statement, you have already mentioned about the use of metadata for of the traffic types to be used for machine learning. So my question is that would it do you think, in your experience with ITU, do you think that standardizing this type of information in metadata will help, especially when you have different types of such networks underneath? So in this picture, if you see this picture, you have different you have a open flow based architecture for the underlying network, right? And you're taking the metadata to be used for training and inference purpose. But another university or another operator may have a different type of network, which is providing another type of metadata, and there may be different types of models which are trained based on these different kinds of metadata which comes from different types of underlying networks. So essentially we have a problem of interoperability or not, whether standardizing this metadata will solve such a problem or not. Could you please comment based on your experience in ITU?
Thank you for this question. So I firstly I would like to come back to this slide. Not this, sorry, this one. Not come back. If we'll talk about this approach, like method which can to have solve the problem now we have in a network in artificial intelligence also tasks. We have the requirements. Requirements is SaaS approach and independence from vendor solutions. Now I mean about open interfaces on the northbound and southbound. And if you're talking about southbound, it's open flow the de facto. We mean open source platforms, cross platforms, and if it and better it if the services can be migrated on another one, for example, servers on the edge of or edge of networks. So, and in this, and we will try to solve the problem of traffic recognition. We have to consider that. So, and one of the approach, for example, is use this a neural networking on edge of networks. As we know now, we have different technologies for computing, cloud computing. There are edge computing, the new approach is fog computing, and for example, as I told above in our presentation, that in one of our work we made the solution when we shared this neural network to edge cloud. And if we will talk about this architecture, we can make more efficiently system, I think. But according to ITU-T standards and the ITU-T activity in a focus group of artificial intelligence, we I think this approach have to be developed.
Thank you. I think that is quite interesting discussion, and I agree that we should probably look at what can be standardized, because there are other standards bodies essentially looking at similar type of solutions. Approaches for using the data from the network for machine learning purposes, for slicing, and for resource allocation. So I think configuration as well as measurement are two different aspects which are being looked at by different standards bodies themselves. So I think your problem statement is quite interesting in that respect. I got one more question in slide 11, I think, which is, could you go to slide? Yes. So here, what do you take as the unit of throughput in the y-axis? What is it? Is it Mbps or something?
Yeah, this is a packet per second.
Okay.
So yeah.
Okay, packets per second. Yeah. So I think the case which you are taking, seems to be quite settling down after some time. It is stable after some time. It looks like maybe if you take say after 10 seconds, is the x-axis seconds, right, or minutes?
Yeah, second.
Okay, so after 10 seconds or so, it looks like fairly stable. Why did you select such a distribution of traffic? Is that by choice, or is that some other design decision which is there? I'm trying to understand the reason for this kind of traffic.
Yeah, we use the same metadata traffic. We do some traffic prediction to show that the throughput will be better in this case. I'm right?
I see. Okay. Yes, Alex is asking, is there a negative throughput on slide 11? Negative throughput, I don't see it, but could you confirm, please, Artem or Dr. Amar, is there a negative throughput here?
No, they are not negative throughput.
Okay, thank you. So the actual throughput, the actual throughput which you are ground truth, the actual ground truth is stable after some time, isn't it?
Yes, you're right. Yes.
Mm-hmm. Is that so? Suppose have you done studies where that varies after some time, or is it better if is the prediction? What I'm trying to ask is the prediction better if it varies or if it stabilizes after some time? I mean to ask if the in this figure the throughput seems to be stabilizing after some time. Let us say if it varies, would the prediction using the metadata technique that you use, have you done studies where after some time it varies, maybe due to more number of sources, or maybe due to some variation in throughput? That's my question.
Okay. No, we didn't do this, but we can extend it.
Okay. I think there is, let me check if there is any other question. Yeah, so I wanted to also ask you about the future directions. So what are your future directions in this research? Where do you think this is going, and how would you extend this in future? Could you please comment upon what are the future directions in this area of work, in general, in this area of research?
Yeah, thank you. So I think at first it will be extend yeah, I mean about different types of traffic. As you know, that Internet of Things have different services which have their requirements to quality or service parameters like latency, jitter, and other one. So this method can to solve a problem with traffic prioritization on the next step. And first step of extended this work, it will be work with more types of traffic. It's one step. The second step will be make an analytical system which will collaborate with the orchestrator of the network, as I talked about a little bit about that. So, for example, in our structure, in one of our papers, we suggested the system when the one of neural networks is located on the edge of edge clouds. You can see here on this slide too about that, and this application, analytical applications, is connected to a control main analytical application, and we collected different data, and then we can make more intelligent system, I think. and collaborate with the orchestrator for increase realizing requirements of IT services. And if we talk about only this method, maybe Dr. Amar could add some information.
Yeah, as Artyom mentioned, there are some hot topics now, like autonomous vehicles and other applications, which requirements are different. So this approach can be usable for that. And also in before Artyom mentioned about migration and microservices and so on. Also, we are going to extend this area.
Yes, now we're working on this special framework for services migration, in which we included in this approach too.
Very interesting. Thank you so much. We are almost time. There is thank you, Amar, and thank you, Artem, for very patiently answering our questions.